the first thing we're going to do is metric estimation, which is just exactly as it says. It's an estimation based on the metric system. It is something that you've been doing every time you do a problem, any time that you're relating it to a laboratory assignment. You're basing it off of objects, and it's about the estimation of that. The one thing that you will have to know is how to convert from one thing to the other. So if you have trouble with that, a good way to do that is by using something that you should be familiar with and see before, which is King Henry died by drinking chocolate milk. So that process there can help you conversion. So this is kilo, hecta, deca. This is your base unit. This is deci, centi, and milli. So question number 1 says, what is the approximate width of a person's little finger? So we know that a person's little finger is about the width of about a centimeter. So based on our choices, which is 1 through 4, we're going to try and determine what the centimeter would be. So if I have 1 meter, that means I'm given my base unit, which is meter, and I'm converting it to centimeters to kind of compare what I do know. So to go from the base unit to centi, you go 1, 2. So that's 2 places to the right. So if we start with 1 meter, we're going to go 1, 2 places to the right. That means I'm left with 100 centimeters. If I have 0.1 meters, 0.1 meters, that means I'm going to go 1, 2 places to the right. That leaves me with 10 centimeters. The next one is if I have 0.01 meters, I'm going to go 1, 2. That's going to leave me with 1 centimeter. And then finally for number 4, if I have 0.001 meter, I'm going to 1, 2, and that's going to leave me with 0.1 centimeters. So based on that, the most logical answer is answer choice number 3, because that's the size of about 1 centimeter. Question number 2, what is the approximate mass of an automobile? So we did an entire unit based on collisions in automobiles. The average automobile is about 1,500 kilograms. And so based on that, we're kind of looking at the different exponent forms to kind of determine what the mass of that automobile is going to be. So if we have 10 to the power 1 kilograms, that means we just have 10 kilograms. If I have 10 to the power of 2, we have 100 kilograms. 10 to the power of 3, we're going to have 1,000 kilograms. And 10 to the power of 4, we're going to have 1 million kilograms, which is exponentially large. So based on this, we know that the closest to the average is 1,500 kilograms. Even if you couldn't recognize that, maybe you didn't know the size of a vehicle, maybe you weren't paying attention through each of the labs for the collision course, based on 100 versus 1 million, you should be able to kind of deduce what your answer choice should be based on the averages of what you think a car should be. And we also had a question very similar to this in your units for collision based on what the average car size was. So you should have been able to get to this question pretty much with no problem. So this is number 3. Okay. We're going to go to question number 4. So we're going to skip to question number 4. An egg is dropped from a 3rd-story window. The distance the egg falls from the window to the ground is closest to which of the following? So if we're looking at that, we're looking at 10 to 0 meters. That's just going to give us 1 meter. So if we know what the size of a meter stick is, we know that that is extremely too small for a 3-story window. 10 to the power of 1, that's going to give us 10 meters. 10 to the power of 1 will give you 10 meters, which again, that's just 10 meter sticks stacked on top of each other. Again, really way too small. 10 to the power of 2 is going to give you your 100 meters, which seems a lot reasonable to get to that 3rd story versus the next one, which is 1,000 meters. So if you judge based on the size that you know what a meter stick is, you should be able to again deduce that the question answer should be number 3. Okay, question number 6 we're going to go to. The mass of a paperclip is approximately which of the following? So we're going to kind of judge based on what you think that a paperclip's mass size should be. For the first one, for question number, what is it? Question number 6. Yeah. For question number 6, we have 1 times 10 to the 6th, which is the approximate mass. Now, if I just look at number 6 already, I already know that 10 to the 1 times 10 to the 6 and 1 times 10 to the 3 for a paperclip is way too large if I've already know that the size of a car is 1,500 kilograms. So I should automatically go down to my choices either being 3 or 4. So if I know that the paperclip is 10 to the power of -3, that means that my answer is going to be 0.001 kilograms. So that's going to be for one paperclip, 0.001 kilograms. And then the other option for the paperclip is 0.00001 kilograms. kilograms. So, based off of that information and knowing what the size of our car is, 1,500 kilograms, one is obviously extremely smaller versus the other. So, if I know that already, I'm going to kind of lean towards the 0.001 kilograms just because this size seems way too small compared to the other one. Even if I didn't, you should have an understanding that one paperclip is about a gram. And so if one paperclip is about a gram, and then we're talking going from kilograms, that would be 1, 2, 3 places to the right. Again, 1, 2, 3, that would be your gram. To kind of compare in something that you're familiar with. So that means that your answer, of course, would be the 0.001 kilogram, which means that this also is number 3. Alright, the next one we're going to do is question number 10. What is the length of a football field? Which of these is closest to the length of a football field? So I'm going to look at each one. I'm going to look at my centi, I'm going to look at deci, kilo, and milli. So if I know that I'm going to base this on meters, just because that's something that's very common with the heights and the lengths, and I also that's the most common length that we have measurements for any time that we were working in the lab. So if I have my base unit, which is the meter, that means that's where we're going to go to. So we're coming from centi off of 1,000. So if I start at 1,000, that's my 1,000 centimeters, and I go to my base, that's 2 places to the left, which means I'm going to be left with 10 meters, which is incredibly small. The next one is coming off of 1,000 decimeters. So if I'm on decimeters, I'm going to go 1 place for the meters to the left, which means I'm going to be left with 100 meters. Okay. Alright. Then, if I go from my number 3, which is 1,000 kilometers, that means I'm going from kilo, 1, 2, 3 to the right. So 1, 2, 3 to the right, and that's going to be 1,000,000 meters. And then the last one would be millimeters, which we're going to go from 1,000, we're going to go here, so that's 1, 2, 3 to the left. So 1,000, 1, 2, 3, that's equal to 1 meter. So if we look at our basis on what we have 10 meters, 100 meters, 1,000,000 meters, and 1 meter. The obvious answer is going to be choice number 2. Okay, So these are estimations. You have to know the metric scale. You have to be able to do the conversions. Please make sure that if you have any questions on how to do any of these, that you do ask these questions anytime during class.